Hello everyone, in this video I am going to demonstrate you an SMPS. This SMPS works with an input voltage of 155 volts to 220 volts DC with an output voltage of 30 volts. This SMPS is designed to drive an LED module. As you can see here, this is the LED module I am going to drive. This LED module is manufactured by Bridgeflux and the model number is 50C4000F. So this is the LED module I am going to drive. I have installed this LED module on an heatsink, and this is the polarity plus terminal and this is the minus terminal. And here you can see this is my SMPS setup. You can see here. So this SMPS input is, this is the input. You can see here, this is the bridge rectifier with a filter capacitor, and from here we are getting 220. We are getting the input voltage between 155 volts DC to 220 volts DC. And here you can see this input voltage is coming here with this blue wire, and here there is a step down unit. You can see this is a resistance. It is 5.6K resistance, and this resistance is stepping down the mains voltage to 12 volts DC. And here you can see this is the control circuit. The control circuit is based on IC TL494. And these are the various control components. Here you can see these are the various control components, and this IC is firing these two power MOSFETs. These two power MOSFETs are finally driving this power transformer. The primary of this power transformer is pulled up with 220 volts. You can see here 155 to 220 volts DC, this pull up line. You can see here, and the secondary of this transformer is fed to this Schottky rectifier, followed by this inductor choke and a filter capacitor. Part of this output, you can see here, this part of this output, you can see from here this black wire is fed here with a diode. It is fed to this resistance. So initially the circuit will drive from here. Initially the circuit will drive from the mains line, and later on the circuit will power itself from its output supply. You can see here from this transformer output, it is taking the part of the output, and it is with this resistance, it is feeding on the same power bar with this 12 volts Zener diode. You can see here this Zener diode is regulating the voltage across this IC TL494. So initially power will be supplied by this 5.6K 5 watt resistance, and later on once the oscillation starts, this resistance 820 ohms 5 watt, this resistance is supposed to give power to the circuit. So this is how the circuit is designed. You can see here, this is how the circuit is designed. So now I am going to gradually increase the power, and we will see the response of this circuit. So now you can see here, the voltage is 0 volts. So let me power up. I have powered up. So here I am gradually increasing the voltage. You can see I am gradually increasing the voltage. The rating is between 155 to 220 volts. So I am increasing. You can see I am increasing. So here you can see still now there is no voltage. You can see now the voltage has started to develop. You can see 167 volts. It is 1.8 volts, 1.9 volts. You can see the output is started to develop. Here it should be 27 volts. So let us increase the voltage further. You can see here at 155 volts DC, you can see at around 147, 148 volts, output is 27 volts DC. You can see the LED lamp is glowing. You can see this is the little far view. The LED lamp is glowing. You can see this is the 27 volts DC, and the supply voltage is 146 volts DC. So here you can see this is the setup. So now I am going to increase this voltage. We will be watching the output. I am increasing the input voltage, and the output voltage is still 27 volts DC. You can see I am increasing the input voltage. I am increasing further. You can see it is 220 volts DC. Still the output voltage is 27 volts DC. You can see, and the LED is glowing. So the output voltage is between 150 volts to 220 volts at an output of 27 volts DC. This is how the setup looks like. So now I am going to shut down the circuit. You can see this is how the circuit works. Thanks a lot. Thanks for watching.